Hello, ladies and gentlemen, and welcome to an AP Environmental Science screencast with your APES teacher, Mr. Snano. And today we're going to look in or delve into environmental science. And we're going to be looking at Chapter 1. This is all based off our Miller textbook that you'll probably become pretty familiar with by within a very short period of time and definitely by the end of the year. Chapter 1, dealing with environmental problems, causes, and sustainability issues. Kind of like a brief little overview of environmental science. One of the first things that we need to look at, and is probably one of the biggest issues with environmental science, is our human population growth. Our human population growth, as you can see here, has remained quite steady for a long period of time, not really moving much, and even really going up into about, zero, not moving much. We have a little bit of a bump here. We saw a little bit of increase, and then the Black Plague took it down. And then at that point, we could see here we have our agricultural revolution. Even during that, when we were able to grow and produce and have more food and energy for people, we really didn't have a high population growth. Not really until this industrial revolution, looking at around 1400, 1500, 1600, where population started to rise. And then really around the 1800, we see this huge increase, this growth right here, this exponential growth. And taking us up to really now at about 7.2 billion people right here. So our population at 7.2 billion people and growing does not really see any chance of slowing down. This right here is our J-shaped curve, basically an exponential growth curve. We'll go over more different types of growth curves, but this is what the human population is experiencing right now. Environmental science, we have basically the Earth has got a number of different life support systems, different spheres that it relies on to basically maintain itself, whether humans were here or not. We can see we have the atmosphere, the water or the hydrosphere, our lithosphere, which is basically everything we're standing on, and our biosphere. These four spheres basically overlap with humans. They're going to our population size, our worldview and ethics all overlap with these. How we feel about the Earth, how our population is able to grow because of utilization of Earth's life support system. Economics based on these right here. Mining, for example, it's going to be relying on soils and rocks within the lithosphere. Economics tied very closely to that, and it's also tied to the biosphere too. Politics, same thing. Wars are fought over mineral resources we find within the lithosphere. So you can see how all of these, how humans are directly linked and tied to Earth's life support system. So the goals of environmental science, basically I consider everything has a story, or there's stories behind everything. So we want to know how nature works, how the environment affects us, and how we affect the environment. And basically, through those interactions, how we can live more sustainably without degrading our life support system or this planet. We can look at a number of different things or this pathway of sustainability. We know we start with natural capital, basically our resources within this planet. Then what happens when we use them, the degradation of those. Once we realize that there's problems or that we could see that there's a lower quality of our resources, then solutions to keep those around, how those solutions impact, what are the trade-offs? So by here, this not cutting or no clear cutting of land, what happens? And then basically what we can do to kind of keep this system going. So sustainability is the ability of Earth's various systems to survive and adapt to environmental conditions indefinitely, which is probably the most important part right here, indefinitely. Sometimes we hear this is for future generations, which is just another way of saying indefinitely. So we want to basically keep everything we have now in the same shape, form, and quality of life that we have now for our future generations. And we want to use sound science to really make this happen, to really keep it going. So we want to basically meet the basic needs of the people in an equitable manner, which is also important. We want to basically make sure that everyone has what everyone else has. without degrading the natural capital, basically Earth's resources, that it supplies us. Natural capital, once again, just kind of go over it, what it is. We have the air, water, soil, land, all those four spheres that we're looking at, these non-renewable and renewable things, energies and minerals, and basically the natural services, the services that they provide to us. So the air, so air purification services, water purification services, water storage, we're looking at our aquifers. So all these things, this is what the earth does for us. And it does it without thinking. It just does it. These are just natural cycles. And what we need to do is understand how each and every single one of these services work. By understanding how these work, we can see how we can maintain these resources to keep our natural capital up for those future generations. This is what this class is about. How each and every single one of these systems work, how the earth does it, how we maybe can copy or simulate how the earth does it, or develop new ways to figure out how we can keep these services going. Sometimes we put prices to these services. Basically, like if we didn't have water storage, how much would that cost us for us to do it? And people have put this number in the trillions of dollars, not billions, trillions of dollars, that these natural services, when you add them all up, what they equal out to us. Economic growth provides people with more goods and services. Basically, we could take everything from the earth and we use it to produce things. Produce things for people, for consumption. So we can look at that at the gross domestic product, basically the money that it does for countries and people, and purchasing power parity, which is basically how we basically look at maybe Japan's monetary unit compared to ours. It has to deal with exchange rates. So we can know that something that costs $50 here, how much it costs somewhere else. That's that purchasing power parity, and it's used to like I said, for exchange rates. Economic development uses economic growth to improve living standards. Okay, if we look at what's going on around the world. So we can see that we have developing countries in yellow, or developed countries in red. So this would be like US would be a developed country, developing countries. You're looking at like, I don't know, anywhere like possibly like in Africa, some parts of the Middle East, and some parts of Asia right there. So these developing countries or your third world countries, you can see the percentage of the world's population is in mostly developing countries. The wealth and income is completely inverse to that. We can see that the developed countries have most of the world's wealth, but we're less of the population. And same thing, resource use, pollution and waste, how it's all tied to these developed countries. We look at pictures of developing countries and it would look like these pollution and waste would come from here. But it's not really coming from them. It's coming from us in the developed nations, because what we're able to do with Earth's natural resources and how we utilize them, sometimes for good, and all of the aspects that are tied to them, or the effects that are tied to using or resource consumption. Let's just take a closer look at it. We can also see increasing level of poverty. If we draw in our equator right around here, this is our equator, and you can see that most of it's tied right near the equator. Okay, what ends up happening here is it's really luck. Maybe the lands aren't as fertile, or just the weather conditions in these areas make it a little bit tougher to live. Okay, we have resources in general, perpetual, basically, they're continuous on a human time scale. We were around for 100 years, 90 years, 80 years, and we see those resources constantly being renewed or brought about. We have renewable. Basically, these can be replenished rapidly. Trees, for example, can be considered renewable. They get replenished within a few years, 10 years, 20 years, relatively short on a human timescale. And then non-renewable, such as oil and coal, that take millions of years for them to basically get regenerated. Okay, I'm going to end here for now before we go on to the next little part. I hope you enjoyed this brief little introduction into environmental science. We're going to keep going next time. Take care.